So what we have here is simulated pit contents, fecal material, so it's about 12% bentonite. And here's the machine. So in the field, it comes with a dolly, so you can actually just roll it in. You can connect whatever length pipe is needed depending on the pit. You can bring several lengths to the site. There's an auger that basically is powered by a hydraulic motor, and that's powered by a gasoline engine which is running in the back. The nice thing is the engine can be 30 feet, 40 feet away. You just need a cable or the hydraulic lines that can stay in the truck, on the road. You know, you don't have to wheel it towards the pit. And this is very portable, can get into a tight space. Okay. Yeah, so you have basically the material going up, and here there's a reverse flight, so that instead of compacting it towards the top, it actually pushes it down here. So it's very simple to operate. Once you get it into place, you just put this on, and it's pumping already. And we can empty a 1 cubic meter pit in half an hour to 1 hour. And nobody needs to get into the pit to empty it out. And so even if it's compacted material, you know, an auger is used to drill holes in soil. So, you know, it can pump this thing out. If something jams, you know, big rocks, for example, or a big piece of cloth, and it won't enter, or it jams inside, you can basically reverse it, and so it will push the thing back. So this is the reverse, and that's just pushing it back down. So it's very simple technology. You know.
What's the auger made out of?
It's made of plastic. It's a plastic flight of screws.
Okay. The core is metal?
The shaft is metal. And we can make it also out of stainless steel if that's a concern. But it's basically off-the-shelf material. We can buy it from a company.
How fast does it rotate?
It rotates around 400 RPM.
You can't change the speed?
The speed, not so much. I mean, we could, you know, it's sort of variable speed in the sense that I can control it here. Yeah, so it's variable speed that way. I can ramp up the gasoline engine, but I think it's roughly around 400 RPM, you know, 300 to 350 to up to 700 RPM. So it's, you know, you can hear it variable speed a little bit, yeah.
Well, I guess it wears out after...
It will, yeah. So there's going to be the other thing that we want to make sure is that the material is going to be, you know, what's the longevity of the material itself. If I'm doing a lot of rocks, obviously it's going to wear out faster. So for fecal material, it's not a problem, but for things in the pit like you know, pieces of glass, rags, not so much maybe. But these are the things that we want to do in field testing. So to us, the best test is to just give it to a pit emptier. And we have some contacts in the Durban area. Give it to them and say, okay, use it for 20, 30, 40 pits, and then tell us what's wrong with it. And then they can tell us, okay, you know, you need to improve this or that, and then that's what we're going to do with continuous iteration. We're going to have a product that's already been field tested by the end of this year, hopefully, and then we can say, okay, for that market, we know it's going to work.
And how many of these prototypes exist currently? Just the one?
So we have, this is version 3. We're calling it version 3 because we already have version 1 and 2 as we iterated during the design process. Right now we have this one that we shipped here. We have one back in at NC State University. Those are the two. And then we have a lab system. That's a motor, and we have an artificial pit. And it's got a clear pipe. And we're doing video with that. We're doing sort of you know, simulations. We can put color dye. We can see how it's being taken up. We can change the waste from watery to very solid waste, and we can add plastic bags and newspaper and so on. So that's in the lab, but of course there's no substitute for the real thing in the field. Yeah.
Okay.
Thanks very much.
Yeah, I know.